Because we'd say if we pluck the sun from the center of our solar system, you wouldn't know about it for 8 minutes and 20 seconds. You'd still orbit, we'd still feel the heat, we'd still feel the gravity, everything would be normal, and then 8 minutes, 20 seconds later, we fly off at a tangent in the dark and freeze in interstellar space. Have a nice day. Yeah. How that's going to happen.
But those 8 minutes before are amazing.
Did Einstein, I don't know that I've seen the paper that did this, did he predict gravitational waves?
Yeah, so Einstein, when he was developing the theory of general relativity, and this was the theory of gravity. So the thing that, so we all learn in school Newton's version of gravity, and Newton's law has been, it's easy to understand, it's intuitive. It says you have two objects that have mass, and they're going to feel a force of attraction between them. And it was quite quantitative. He said the force of attraction will be proportional to their masses and inversely proportional to the square of the distance separating them.
It's very clean. That's a clean operation.
You know, we teach it in very early sort of first encounters with physics, and it was quite successful. It told us about how orbits would work, and it also had pretty early on places where it didn't work perfectly. Now, what Einstein, when he was thinking about gravity, he kind of turned it on its head. And he said, well, look, gravity's not really a force. Gravity is the geometry of space-time. Big words. But he had a series of papers, 2 or 3, from 1915 to 1918, in which he sort of formulated this theory of general relativity. He wrote down what are now known as Einstein's equations. They look not that much worse than, say, Newton's law, except they're quite beastly. They're very difficult to solve. But part of that work was that he did ask the question, what happens if whatever object you're thinking of isn't just sitting still in space? What happens if it's moving, and not just moving at constant velocity? What happens if it's accelerating? And then out of his equations popped this wave-like object, which he called gravitational waves.
Wow.
And the other thing
I want stuff like that to pop out of my equations.